next time I draw these, I'll try and do this triangle pointing that way, get this pointing so they're right on each other. This is okay. Try and angle those, because that would be on the same plane, because the distances is what we're focusing on right here. 2.90, 2.85. Oh, that actually is closer. Shouldn't have made that bigger. I should have made that one bigger. So the point is, though, that there's 2 bonds in there. The next one's going to have 3. Now we're going to compare these two, the cytosine and the guanine, 3 bonds. This is going to end up being 110, 1.08. Try that. Okay, so we're going to start right in the middle, because this is what we were focusing on, were the ends. Cytosine is a 1-membered ring. Guanine's a double ring, but it's still the ends that are closest to each other. So we're going to look ahead, and we're going to put the pointy one with the H on it, so it's pointing up that way. And then this H, we want to have the aliens, so this one goes flat. Actually, look, you can draw them both the same way. How about that? So what we're focusing on here even though in reality, I know from being a spectroscopic chemist, the proton will get the same distance in between there and do a little dance. But that's not what we're focusing on here. We're focusing on which ones are doing which. So the mind meld is coming from here. So that's going to be green and yellow, right? And we were saying that this was, I'm going to call it 286 picometers. They're showing it as a decimal with the nanometers. Forget that. Okay, so now there's going to be 2 more. So let's finish the ring around here and see where this goes. Whenever you got an end, there's going to be carbons on both sides, because we know none of the ends are connected, but there is 1 carbon in between them. So let's work off this way to a diamond. This way to a diamond. It's going to have double bound O to it. So let's go up that way. Now this carbon goes double bound down. To a diamond. So we didn't even care about that yet. Now if you want, you can start doing some of the double bond stuff here. Double bond here. Now, coming off this is going to have an N that's going to have the H. So we want the pointy part up, just like that one. That way the hydrogen's proton is right there. So this gets a little proton too. So what's interesting now is that both the ends here are ones that are providing the proton. This one over here can be a receiver. So let's work off this end a little bit, clean it up a little, see what's happening here. Looks like a double bond to a carbon to a nitrogen. So let's go. Carbon. Now this nitrogen, remember, is going to be one that's going to be providing the proton. So have it go straight up. It's not much of a right angle, is it? It's a little bit closer than I wanted. Okay, now this one is actually the furthest, so I want to make sure we set that back a little bit. You can do the little mind meld now if you want. We could do the double here. Outside the line, because there's a lot of electron density here. That's what's coming up out of the page, is what a pi bond's doing. Okay, so that's two. We got a third one over here. So nitrogen to a carbon. And that carbon will have a double bonded O, right? Yep, it's got to. So it's going to have the alien here. This is 284 picometers. This is 283. So the sides are closer than the middle, which doesn't really show that there, or here for that matter. 283, that's actually the closest, and it's drawn the furthest, so we got to fix that. Okay, that should be the furthest. So here's O coming all the way close. H, calling it O, but it's a circle. And we'll have to get this one closer. Get them real close, I guess. As long as you know where the H is. That's what the important part is. The H is on the end. H is on the end. H is on the end. Look at that. They're all on the ends. But see, that end, that's what's confusing. You're like, well, what's it on? It's always on the end, except here you got an end that is end to end. So it's going to have to be the acceptor. See, I'm learning by doing this. What I want you to see is, you know, the excitement of it. If I do this a million times and then I sit down and do it, you know, to make it look professional, I lose my flair for it. You can't fake that initial discovery. So I'm learning now. We've done this quite a few times, drawing the DNA with the Schroeder diamonds, but this is actually the best, I think, because we're focusing now, boy. So let's save tape. We're going to pause it and color some of this in. Okay, so we colored some of these in a little bit. What we got to do is finish the ring up here, and then we're going to have to finish a whole new ring down at the bottom. So let's start at the bottom down here. We're going to have a 5-membered ring coming off here. So the first place this is going to go is to the ends. So we've got one end coming off here. Are we on camera here? Okay. There's an end. There's an end. This is how it's held. So that one goes off. 2, 4. It's a 5-membered ring, so see if we can draw this up this way a little bit, because it's going to want to do a double bond to a diamond there. So there's the diamond. Here's the double bond. Connect the carbon. So that's done. It gets an H on it. Nitrogen's done. Put electron alien in there if you want. That nitrogen's done. So see, like I said, after a while you want more complicated stuff because you're going to get more colors and it'll look cooler. This was so simple now. That's a 1, so what's going to get brown? So the double ring, they call it the purine. Well, this is G. Guanine. Okay, now let's finish the top up here. We've got a nitrogen, because that's part of the ring. So 1, 2, 3, 4. This is a 6-membered ring. So let's come off this carbon here. Oh, we got the double bond carbon. So it goes to a single carbon, to a double bound carbon, and that goes to the end, and this end goes off to the side. So we colored that ahead of time just to keep things colorful. So color the double bond first. If you've watched our older videos, we've perfected the technique now. First off, double bonds. And gosh, we're so simple now. I mean, God, we put the hydrogens on. Nothing too